so in this particular problem, we have two blocks, block A being on the left, block B being on the right. Block A is 0.6 kilogram, block B is zero point 0.9. Block A is initially moving rightward at a rate of 4 meters per second, and then block B is moving leftward at a rate of 2 meters per second. They are going to collide and then couple together or stick together. Part A wants us to find the velocity of the blocks after the collision, and then part B asks us to find the energy loss during impact. All right, so let's go and crack out part A. To find the velocity of the block or system after collision for this one, since they are stuck together, you would just set up conservation of linear momentum. So the net momentum initially equals to the net momentum in the final frame. Here, I'm just going to break net momentum into two terms. There are two terms because there are two blocks initially moving. Here is PAI plus PBI, and that would equal to PAF plus PBF. And then you can expand P to equal MV. And then if it's PAI, it would have to be MAVAI. Likewise with PBI, it would have to be mass of block B, and then VBI, and then likewise on the right side. Okay, so the only difference on the left side and right side is the subscript I and F. Here, I'm just gonna go ahead and combine like terms on the right side. So keep in mind that it says that the blocks are going to collide and then couple together. So the phrasing here says couple together, which implies that they have the same final velocity after they are stuck together. So on the right side of the function here, I just replace VAF and VBF with simply VF. Why? Because they have the same final velocity, and that allows me to factor out VF on the right side. So really, you would just have two blocks moving together, and that would make sense because it's MA plus MB, because now you treat the blocks as just one block because they're moving together. All right, I'm just going to go ahead and plug values in. MA is 0.6, VAI is a positive 4 because it's moving rightward. And then MB is 0.9, that's given in the diagram. And then it's important that you pay attention here. VB in the diagram has a value of 2 meters per second. However, the arrow for the velocity is pointing leftward. So I highlight the negative sign here. The negative sign here is super important because if you forget about this negative value, because VBI here is the initial velocity of block B, you need the direction because it is velocity dependent. Okay, so don't forget the direction. Other than that, on the right side, it's just adding the two masses together, 0.6 and 0.9, and VF here is the only variable you don't know. So calculator work time. If you simplify all this stuff on the left side, you'll get 0.6. And if you add 0.6 and 0.9, you get 1.5 because now the blocks are moving together as one whole. And then here to get VF by itself, you would just divide both sides by 1.5 and voila. You will get an answer of 0.4 meters per second. But the phrasing or the wording here in choice A uses the term velocity. So because it is velocity, I do need to provide a direction in my final response. So it would be positive 0.4 meters per second. So after the collision, the system will actually continue moving to the right at a slow rate of 0.4 meters per second. All right, let's do part B. Part B asks you to find the energy lost during impact. So this is an inelastic collision that's stuck together. So energy or kinetic energy is not conserved. So therefore, to find the energy loss, you would just take KE of the system final and then minus that from the initial energy that was in the system. Okay. Here, KEF can be broken down to 1/2 mv squared, but the masses in this case would just be the sum of the two masses because they now want to get moves at as one unit. VF squared and VF we just found on the left side here in part A, which is 0.4. And then KEI is super easy to do. KEI, because both blocks are initially moving, each of these blocks have an initial kinetic energy, so it would just be 1/2 mv squared plus 1/2 mv squared. Just make sure you plug in the right mass that correspond with the right speed. Okay. All right, so I'm going to go ahead and do it. MA plus MB, once again, 0.6 plus 0.9 is 1.5 kilograms. VF here after the collision is 0.4 because I found that in part A, and I want to square that. And then here, just make sure you do your calculator work correctly. So I notice I put here KEI system, the whole of term here in parentheses. So here is 1/2 times 0.6 for MA. It is initially moving at a speed of 4. Square that, and then add it to the kinetic energy of block B. So even though it's moving left, it has a kinetic energy, and kinetic energy is a scalar. So here's 1/2 times 0.9 times 2. Here the 2 represents speed for block B because KE once again is a scalar, so you don't need to necessarily put a negative 2 here. And then you square that. Take care of this bracket first that I'm circling back and forth here for KEI. So make sure you do your algebra carefully. So if you simplify this, you get 4.8 plus 1.8. So these two terms will simplify down to 4.8 plus 1.8, and then you would add those. So 4.8 plus 1.8 will give you 6 point, what is that, 6.6? And then from there, you would just take the difference. So 0.12 gets carried down minus the sum of these two energies in the bracket there. So therefore, you'll get negative 6.48 joules. And that is your answer for part B. All right, stay nerdy, don't be whack.